Hello and welcome to today's lesson on calculating average speed for non-uniform motion. Our plan is as follows. We will begin by explaining what non-uniform motion is and why it complicates our understanding of speed. We will then introduce the idea of average speed and what this tells us. Finally, we will work through examples of calculating average speed to consolidate our new knowledge. So far, you have learned to calculate speed using the formula speed equals distance over time. Building on this foundation, we can now introduce the concept of average speed for non-uniform motion, which provides a more comprehensive understanding of complex journeys and how varying speeds and pauses affect overall travel. Let's get started. To motivate introducing average speed, let's consider the following scenario. Imagine you are walking from your house to the park. You begin by walking 20 meters at a speed of 2 meters per second. You then stop to tie your shoelace for 1 minute. After tying your shoelace, you walk another 15 meters at a speed of 3 meters per second to reach the park. As you can see, your speed throughout this journey varies a lot. At some points, you're moving quite quickly. At other moments, you are stationary. In physics jargon, we say your motion is non-uniform. For these reasons, we need to consider your average speed across these various moments. Let's now turn to how we calculate this. The average speed is given by the equation. Average speed equals total distance traveled over total time taken. Let's apply this to the earlier scenario we sketched out. First, we will calculate the total distance traveled on the walk. During the first part of your journey, you walked 20 meters. While tying your shoelace, you didn't travel any distance, so it's 0 meters. In the final part, you walked another 15 meters. Hence, the total distance traveled can be calculated by summing these distances. Total distance equals 20 meters plus 0 meters plus 15 meters, which equals 35 meters. Next, we'll calculate the time for each part of your journey. For part 1, we need to find the time taken to walk 20 meters at a speed of 2 meters per second. We use the formula speed equals distance over time, rearranged to time equals distance over speed. Time equals 20 meters over 2 meters per second equals 10 seconds. For part 2, you stop for 1 minute to tie your shoelace. We need to convert this time into seconds. 1 minute equals 60 seconds. For part 3, finally, you walked 15 meters at a speed of 3 meters per second. Again, using the formula, time equals distance over speed. Time equals 15 meters over 3 meters per second equals 5 seconds. Therefore, the total time taken for the journey is total time equals 10 seconds plus 60 seconds plus 5 seconds, which equals 75 seconds. Now that we have the total distance traveled, 35 meters, and the total time taken, 75 seconds, we can find the average speed. Average speed equals total distance traveled over total time taken. This gives us average speed equals 35 meters over 75 seconds, which is roughly equal to 0.47 meters per second. For simplicity, we can approximate this as 0.5 meters per second. While this average speed may seem low, it's important to remember that you spent a significant amount of time, 60 seconds, standing still, which affects the overall average. Let's apply what we've learned to a few specific problems to consolidate our new knowledge. You walk 30 meters to a bus stop at a speed of 3 meters per second, wait 2 minutes for the bus, and then walk another 10 meters to reach the bus, traveling at 2 meters per second. Let's find your average speed. First, we determine the total distance traveled. In the first part, you traveled 30 meters. In the second part, you travel 0 meters as you are waiting. In the third part, you travel 10 meters. Hence, the total distance traveled is 30 meters, plus 0 meters, plus 10 meters, which equals 40 meters. Next, we have to calculate the total time taken. In the first part, we use the equation time equals distance over speed, so 30 meters over 3 meters per second, which equals 10 seconds. In the second time, the waiting time is 2 minutes, which is 120 seconds. In the third part, we use time equals distance over speed to find 10 meters divided by 2 meters per second, which equals 5 seconds. The total time equals 10 seconds plus 120 seconds plus 5 seconds, which equals 135 seconds. Now we can find the average speed. We need to use the equation average speed equals total distance over total time, so 40 meters over 135 seconds, which is equal to roughly 0.3 meters per second. Let's try another scenario. A cyclist rides 50 meters at 4 meters per second, stops to repair the bike for 3 minutes, and then rides another 30 meters at 6 meters per second. Calculate the average speed of the cyclist. First, we determine the total distance traveled. We travel 50 meters, then 0 meters, then 30 meters. So the total distance equals 50 meters, plus 0 meters, plus 30 meters, which equals 80 meters. Next, we calculate the total time taken. In the first part, we use time equals distance over speed, which equals 50 meters over 4 meters per second, giving us 12.5 seconds. The repairing time took 180 seconds. Then final part took 5 seconds. Hence, the total time taken is 12.5 seconds plus 180 seconds plus 5 seconds, which equals 197.5 seconds. Now we can find the average speed. We use the equation average speed equals total distance over total time, which equals 80 meters divided by 197.5 seconds. This is roughly equal to 0.4 meters per second. Let's go through one final example. A hiker walks on a trail for 100 meters at 5 meters per second, rests for 4 minutes, then hikes another 60 meters at 2 meters per second, rests again for 2 minutes, and finally hikes 40 meters at 4 meters per second. Find the average speed of the hiker. First, we determine the total distance traveled. In the first leg, the hiker travels 100 meters, then travels 0 meters when they rest, then travels 60 meters in the second leg. The hiker then rests again, before traveling 40 meters in the third leg. Hence, the total distance is the sum of those distances, which equals 200 meters. Now we calculate the total time taken. The first leg takes 20 seconds before the hiker rests for 240 seconds. In the second leg, the hiker walks for 30 seconds, before resting for 120 seconds. Finally, the hiker then hikes for another 10 seconds. Hence, the total time is the sum of these sections, which gives us 420 seconds. Now we use the equation average speed equals total distance over total time, which in this case is 200 meters over 420 seconds. This is roughly equal to 0.48 meters per second. These examples guide you through the process of calculating average speed for non-uniform motion by considering varying parts of the journey with different speeds and periods of rest time. Through more practice with these sorts of problems, you will feel comfortable summing distances and times to calculate the average speed accurately for any non-uniform motion scenario. In today's lesson, we learned about calculating average speed for non-uniform motion. Using a journey from your house to the park with varying speeds and a stop as our example, we demonstrated the steps involved in the calculations. We first identified the total distance traveled by summing the distances for each part of the journey. Then we calculated the total time taken by determining the time for each part and adding them together. Finally, using the formula average speed equals total distance over total time, we found the average speed for the journey. This process highlighted that average speed takes into account both the time spent moving and any pauses during the journey. This skill is essential for interpreting real-life scenarios where speed and motion are not constant. Watch the rest of the GCSE physics course at Sophos Education.